All right, for today we're going to talk about exponents. Exponents is a gateway to higher level math that we'll see in other chapters. This will be the ending of the arithmetic chapter. So now let's talk about exponents. I'll dive right in and show you how we write exponents. So let's look at 3 to the second power. Yes, I said 3 to the second power. This 3 is what's called the base, and that 2 is what's called the power. So if I have 3 and this 2 above it, that means that we have 3 to the second power. Or in other words, another way of saying that 2 is not second power but squared. Okay, so whenever you have a number to the second power, we can say it's squared. So this would actually read 3 squared. This is 4 squared. This is 5, not squared, but cubed. You see, this power can change to any number. So now this would be cubed. This would be 5 to the third power or 5 cubed. Great. Now, let's find out what this even means. Well, regular numbers, or numbers with powers that you don't see, look like this. 3, 5, 6. We're familiar with these integers, but actually they do have a power. Their power is 1. Since it's 1, we don't care and we don't put them there, but they still are there even though we don't show it. All this means is when you have a number a, and a is a variable for any number, and you take it to some power, I'll call that power n, and we'll get familiar with working with these variables. But if you have a number a, or an integer a, any number, to the power of n, that means that we're multiplying a by itself n times. Okay, we're continuously multiplying a by itself n times. So if we have something like a cubed, then we're going to have that equal a times a, that's 2 times another a. And so that's 1, 2, 3 times. Great. And now looking up at what I put before, what I talked about before, this 3 squared would be 3 times 3 equals to 9. So yes, 3 squared is 9. And that's the basics of exponents. Once you understand this, you can do many more problems, such as, let's take a look at this expression, okay? Let's have 6 squared minus 6 plus 6 cubed, okay? So we have 6 squared. 6 squared is 6 times 6, or 36, minus 6, well, 6 to the first is just 6, plus what's 6 cubed? Well, let's take an aside here and find out what 6 cubed is. So 6 times 6 times 6. 6 times 6 is 36, times another 6. What is 36 times 6? So that would be 216. Great. Now we have plus 216. Okay, so now we just have to do 36 minus 6 plus 216. So 36 minus 6 is 30, plus 216 is 246. So that's our answer. This number here is 246. Great. So that was an expression with exponents, and now we can have different processes like cubing and squaring, and those are just words that represent taking a number to the second power or taking a number to the third power. All right, awesome. And so I'll just write those words down so we're familiar with the terminology. So if we wanted to write 3 squared, it's 3 to the second power, so this is 3 squared, and this is what's called squaring 3. We're taking the square of 3, so we're squaring 3. So I'll just write, so that's squaring 3. Okay, great. And cubing 3 would be similar, 3 cubed. And now, what if we wanted to go backwards? We know that 3 squared equals 9, so I'm going to write a 9 here. But what if we wanted to do something called taking the square root, I'll write this root in blue, taking the square root of 9. So taking the square root of 9 is doing the opposite of taking the square of 9. If 3 squared is 9, then the square root of 9 would be 3. Okay? So the square root of 9 is 3. Of 9 is 3. Okay? And we know 9 is 3 squared, so we can say the square root of 3 squared is 3. Now, we're talking about math. We can't write out English words all the time, so how do you represent taking the square root of a number? We represent the square root of a number by this. So the square root, this means the square root, okay? This is a sign used by this to represent that. And now for the number, we put that number inside the square root. We put the number in there. So if we wanted the square root of 9, that would be radical 9. All right, so yes, this square root can also be called radical. So I'll write that here, radical or square root. So two acceptable words or phrases for this would be the square root of 9 or radical 9. And now we know that equals 3. We know that equals 3 because 3 times 3 equals 9. Okay, so for square root, you're finding what number multiplied by itself equals this number inside the square root. So the square root of 16 would be something times something equals 16. Well, that number is 4 because 4 times 4 is equal to 16. All right, and now we can try even the square root of 36 would equal 6 because 6 times 6 is 36. All right, and then we can talk about something that's not a square root but a level up, which is the cube root. All right, and as the name sounds, it's the cube root, meaning taking the third root of a number. And so we don't represent it by this square root, but we put a 3 here to represent cube root, okay? So what do we get when we have the cube root, or try and find the cube root of 27? So it's not what number multiplied by itself equals 27, it's what number multiplied by itself 3 times equals 27, okay? So what number times itself 3 times equals 27? That's 3, because 3 times 3 times 3 equals 27. All right, great, and you can keep on going. You can take the fourth root of a number, the fifth root, and so on. All right, great, and that's how you take the square root of a number. So now I'm going to go over how to take powers of negative numbers. All right, so before that, this is what we talked about. We talked about taking the power of a, where a is just a number. We talked about taking the root of a to the n. And then we talked about taking the third root of a to the n and so on. Okay, so we talked about this so far. And now let's talk about how we take the same operations but for a negative number. So if we have, or the opposites of these operations for a negative number. So if we have b to the n, where b is less than 0, negative numbers are less than 0, then we get a couple of things. It depends on b, okay? So what if we have negative 2 squared? That would be negative 2 times negative 2, which is 4. That's pretty obvious. What if we have negative 3 cubed? Well, that will not be 3 times 3 times 3, which is 27. That would be negative 3 times negative 3 times negative 3, which would equal negative 27. So the rule is, I'll write this here, if n is even, then a or b to the n power, even if b is negative, will be positive. So for positive, I'll write a plus sign, and that works for fractional numbers too. So if n is even, then b to the n is positive no matter what sign b is or what number b is. And great, so now what if n is odd? You guessed it, then b to the n would be negative. Okay, great. So that means that negative 4 to the third power is a negative number. 4 to the third power is a positive number. All right, and whenever you're taking numbers to some power, you just multiply it by itself that number of times. If it's an odd number of times, it'll always be negative. Great, so we went over a couple of other rules or some tricks. I mean, you could have figured this out just by doing the work, but it's great to know that you should be getting a certain sign once you're doing these problems. All right, and now what's another way of writing negative 3 to the third power, a negative number to the third power? So you just write it as negative 3 times negative 3 times negative 3, but the interesting part is when you take a number to a negative power. All right, so we know how to take negative numbers to positive powers, but what if you have b to the negative power? So n is positive, but n is negative, of course. That you would just do as, take the coefficient here. The coefficient here is a 1. It's an implicit 1. We take that coefficient, write it on the numerator, and then on the denominator, we write b to the positive n power. Okay, so we ignore this negative, and these guys are the same thing. Okay, so let's try an example. What if we have 3 to the negative 3 power? Well, we know 3 to the third power was before was 27, and 3 to the negative third power, or negative 3 to the third power would be negative 27. What about 3 to the negative third power, or to the negative 3? So that would be 1 over 3 cubed, and so that's 1 over 27. Awesome. So that equals 1 over 27. You see, it's a reciprocal. Now, what if we have something like, how about negative 4 to the negative 4 power? Well, that would be negative 1, since this coefficient is negative 1, divided by 4 to the 4th power. Well, we would find 4 to the 4th power, and that would be 4 times 4 times 4 times 4, and that would be 256, so we would get negative 1 over 256, which is some fraction or some decimal. Great. Now that we know how to do that, let's solidify that rule. Okay, so this is the rule. B to the negative n power is 1 over b to the n. The general rule is, I'm going to write a as a coefficient of a number and x as a variable. So in this case, x would be 3, and a would be this 1 here. Okay, so a is a coefficient. Just so you guys don't forget, this is what the coefficient is, and x is the variable, and n is, of course, the power, which we're making negative. So this equals a over x to the n power. Wonderful. This is the general rule that you should either copy down or just memorize, all right? And as we do more problems, it'll become clear. So I'll give you a couple of other rules that should be obvious, but it's nice to have them down, okay? So these are some rules. Let's look at number 1. And some of these will be ones that we've done. So radical a, or square root of a squared, would be a. Why? Because we know that the square root of a number is going to be the root of the number, or the number that when multiplied by itself gives you a. So remember before we had the square root of 9, that is 3, because 3 times 3 gives you 9. But what we're doing here is taking the square root of 9, or I'll write 9 here, 9, and then we're squaring it, okay? So then what does that mean? That means that the square root of 9 is 3, and if we square it, that'll just give us back 9. So we can write this rule that the square root of 9 squared equals a. And in this case, a is 9, so the rule is the square root of a squared is a. Okay? So the square root of b squared is b. Whatever number a is, you take the square root of it and then square it, and you know that these two things cancel out. Those two things that are the square root and the square. Okay? So those cancel out when you're taking a square of the square root. And now, what if we have the same thing but for cubed? So if we take the cube root of a to the third power, then that would just be a again, all right? So this 3 has to match this 3, and they cancel out, and you just get a. So the actual general rule here, which I'll box, is, well, we need to make a general variable for 3, so that would be, the root would be b, okay? And then we have this root sign of a, our number inside, to the b power would equal a, all right? So that's our rule. Great. So now rule number 2, and you can practice this and see if it works out. So rule number 2 would be that square root of a squared also equals a, and that's the same thing, you can tell, all right? And I'll just show you. So before we had that the square root of 9 is 3, but now what if we had the square root of 3 squared, okay? So the square root of 3 squared would be here. So the square root of 3 squared, well, 3 squared is 9, so the square root of 9 is 3. Or you could just do this. You can just imagine that this 2 and the square root sign cancel out. And of course, that'll work for cubes and so on. So the general rule now is that the cube root of a to, instead of me writing cubed, let me write it as a general rule, which I said I would do. So we have the nth root of a to the n power equals a. And really it doesn't matter which variables you use, they're just going to be filled in with numbers, okay? So the nth root of a to the n equals a. Awesome, so now on to our third rule. Number 3, we have radical a times radical b. So what happens if we take the square roots of two numbers and multiply them, then we get the square root of ab. So yes, an example of that would be the square root of 9 times the square root of 16. That would equal 3. So the square root of 9 times 16. And 9 times 16 would equal, what does that equal? Well, we know whatever it equals, it has to be equal to AB. So 9 times 16 is equal to 144. And the square root of 144 is 12. All right, and to double check that, we have that the square root of 9 is 3, the square root of 16 is 4, and 3 times 4 equals 12. So yes, 12 equals square root of 144, which also equals 12. All right, great. So that's another rule. And now let's talk about our fourth rule. We have that, what if we have the square root of a fraction? So the square root of a over b equals the square root of, let me write this better. So the square root of a over b equals the square root of a over the square root of b. So like the rule says, we have, let's try the square root of 4 over 9, which equals the square root of 4 divided by the square root of 9, which equals 2 over 3. So the square root of 4/9 is 2/3. And of course we can generalize this to any nth root. For example, what if we take the cube root of 27 over 64? That would be the cube root of 27 over the cube root of 64. And now that would be 3 over 4. So the cube root of 27 over 64 is 3 over 4. Great. Now we can talk about other ways to do these problems. I'll just show you guys one other trick, okay? So before we had the square root of a squared. Well, whenever we have the square root of a number, that's the same thing as saying that number, which is a squared, to the 1/2 power, okay? This square root means to the 1/2 power, and whenever you have something like this, the rule is that if you take a number to a power, you multiply the power of this number times the power of this. So 2 times 1/2 is just 1, so this is the same thing as a to the first power, which is a. And that's why the radical a squared equals a. Okay, and we'll go over this in more detail later on. But you have the basics down now, which is great. So we'll move on to a challenge question next. All right, so here are some problems for the exponents part, the exponents chapter that we did before. So the first one, what is radical a times radical b times 4 times radical 8? Okay, so radical a times radical b times radical 4 times radical 8, give me that answer. Number 2, what is radical 81 times the cube root of 27 to the 9th power over radical 120? So give me that answer. So you guys should pause the video, try it out, and see if you can get the answers, and then come back. All right, here we are back again. Let's go over number 1. I'll do this in red, okay? So here's number 1. So we have radical a times radical b times the square root of 4 times the square root of 8. And what does that equal? Okay, so remember the rule that, I'll write that here in blue. This is just a rule. Radical a times radical b is the same thing as radical ab. And this is where it comes in handy, because now we can combine these numbers. Because it's not always the case that you get the square root of a number. Sometimes you need to combine them. And in this case, we want to simplify, so we need to combine all of these guys. So radical a times radical b times radical 4 times radical 8. We multiply everything inside to get this. So we have 4 times 8 is 32. So 32ab. And that is our answer. But we can simplify it more. It's okay if you don't in this case because we're just starting out, but I'm going to show you guys what the proper simplified answer is. So I want to take these apart, even though I condensed them. The reason I want to take this apart is because I want to have a part that is a perfect square, meaning that if I take the square root, I'll get an integer, and a part that isn't a perfect square. Okay? So as an aside, I'll get back to this. A perfect square are numbers like 16, 81, 9. Why? Because the square root of 16 is 4. And that's my operation. The square root of 81 is 9. So let me just... Okay, so then the square root of 9 would be 3. All right, so you see that if you take the square roots of these perfect squares, then you get an integer. But one number that's not a perfect square would be something like 32. You can't take the square root of 32 and expect to get some number that's an integer. So what you have to do is break it apart. Well, if radical a times radical b is radical ab, then it's fair to say that radical ab is radical a times radical b. We can go backwards. In that case, what I want to do here is then take this square root of 32 and rewrite it as two numbers that multiply to 32. Rewrite it as a product of its factors. Well, we know that 4 times 8 is 32, but we can go even better. We know that 16 times 2 equals 32. And so radical 32 would actually be radical 16 times radical 2, and we know radical 16 is 4. So this would be 4 radical 2. All right, radical 2 is not a perfect square, so we keep it as that. And so why did I show you guys this? I showed you that because now we want to break this apart. And we want to write this as radical 16 times radical 2 times radical AB. Because this becomes 16, becomes 32. And so we can rewrite that as 4 radical 2 times radical AB. And of course, we don't want these separate radical signs. We just want to combine everything. So this would be 4 radical 2AB. Do you see how we combined this square root of AB and the square root of 2? We combined what was inside and got square root of 2AB, and we kept the 4 outside. All right, there are multiple ways of doing this. For example, you could have just changed this square root of 4 into a 2, but I wanted to show you how you can condense and then expand. All right, so it's a process of condensing and expanding until you get the condensed form that is the simplest, all right? So when they say simplify, you're going to get the most condensed form as possible. You do not want to have all of these different terms. You want to have one term. And that term that we got here is 4 square root 2ab. All right, great. And so that was just the first one. Now let's go over number 2. I'll copy down number 2 here. So let's see. We have radical 81. So we have number 2 as square root of 81 times the cube root of 21. Sorry about that. The cube root of 27 to the 9th power, I believe. And so, yes, and then all over square root of 120. All right, let's do the numerator first. We have the square root of 81 we know will be 9. The cube root of 27 is going to be 3, and 3 to the 9th power is some number. But we can do better than that. We know that the cube root of 27 is actually 27 to the 1/3, which I explained in the previous video. You just take whatever root it is and reciprocate it, just like the square root of 4 is 4 to the 1/2. So the cube root of 27 is 27 to the 1/3. But don't forget that 9 that we have on top, and now we divide it by the square root of 120. All right, great. So now let's move further. 9 times this guy here. What is 27 to the 3rd time to the 9th power? Well, these two things multiply. So 1/3 times 9 is actually 3. So we have 27 cubed. Awesome. And then over square root of 120. And as an aside, you should always simplify every term before you start multiplying things out. So what I mean is, I don't want to start trying to find out what 27 cubed is before I simplify square root of 120. Because you may get some things that cancel out, and you don't want to miss that opportunity because it saves you work. All right, so we recopy the top, so that becomes 9 times 27 cubed. And now, this square root of 120, let me just bring this to the side. This square root of 120 is something that I want to break apart, to expand into maybe a perfect square if we can find one. So 120, is there a perfect square factor of 120? Yes, there is. Isn't 120 the same as 10 times 12? Okay, so if 120 is the same as 10 times 12, then these two are the same. And then we can break this apart as radical 10 times radical 12. All right, great. And now, we don't have a perfect square yet, so we can go even further. We can say that the square root of 12 is the same as the square root of 4 times the square root of 3. Because isn't 4 times 3 12? Yes, it is. And bring down the square root of 10. So now we have the square root of 10 times the square root of 4 times the square root of 3. Are any of these perfect squares? This is. So we have 2 times the square root of 3 times the square root of 10. All right, and we always simplify by putting the integer first. So we have 2 square root of 30. All right, that radical 3 times radical 10 becomes a radical 30. And there's no factor of 30 that is a square root. The only factors of 30 we have are 2, 5, 6, 15, and 30. None of those are square roots. And 1, but we don't include 1. All right, so now we have on the bottom 2 square root of 30. Awesome. So now we can really simplify. All right, so unfortunately, this does not work out so beautifully, but we can still write what the answer is. We have 9 halves, 9 over 2, 27 to the third power. What is that? So we have 27 times 27 times 27, and that's 19,683 divided by 2 times radical 30, and sometimes it won't be beautiful. Okay, so we just find out what 9 times this number is, and that would be 177,147 divided by 2 radical 3, or 2 radical 30. Awesome. So that is the answer. We can go even further just by dividing that number by 2 if we want. And so we get, this is 88,573.5. And so we have 885, or 88,573.5 divided by the square root of 30. All right, awesome. And so that's the